All right, this is really kind of important to understand. This is Oumuamua. They say this basically is our region in the solar system. It came in from who the hell knows where. But I'm going to tell you what that is. That is biology, just as all of these others are. I'm going to explain it to you right now. Okay, the biggest bang for the buck is Bennu, and we went from Earth to Bennu, back to Earth with a chunk of it, and here is that chunk. All right, just so you know, here's where these things are in our solar system. The Sun here, Earth, Psyche is over there, 67P is out here, and Oumuamua is out there. Now, Oumuamua, they say, came from out of our region in, and is slingshotting back, I guess, out. I'm not sure what they think about that, but I do know what it is. And I know what that is. I know what this is, and I know what Earth is. And they are not as advertised. This is what they brought back from Bennu. They say that there's no contamination here, absolutely clean. I agree with that. And this white stuff is phosphates, and they're in layers. There's a white layer here, then these blocks, then another white layer, then more blocks, and then block, 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 and you can see some form of a structure in here. I know what this is very, very clearly, and I know what phosphates are very, very clearly, and I will show you, and you will as well. All right, I want you to look carefully at this. We've got a layer of what I call membrane, which it is, phosphates, a layer of sarcomeres, which are muscle, which it is. Laminated over the top of that is another layer of phosphates, because every membrane is made of phosphates. And these are the muscle sarcomeres in a close-up. That's what muscle is made of, these little blocks. And they found DNA, RNA, all the chemical signatures, and not only that, so now we're seeing an actual body part. That's a chunk of meat, which is muscle in a heart, and I'll show you, there is no question about this. That's the same thing right there, only this is on Earth from a heart attack victim. And these are the sarcomeres, and on top of the top and below of each sarcomere is the phosphate layers. And that's why they can slip so easily. And the coefficient of friction on synovial stuff, which is this synovial juice on each of these, is almost, there is nothing even close to how slippery that stuff is. And that's another thing you got to think about in biology, is how slippery these things are. You have to exercise things to keep them pulled. That's a whole other issue, because this is kinetic. All right, kinetic, that means it's being pulled, it's under tension, it turns into a very, very, very sloppy fluid. Before that, static, it'll start to lock up on you. See 0.01, and it goes way out to 0.003. So you got to stay moving around. Anyway, that's a whole other issue, but there's nothing that's by itself. So we're seeing the sarcomeres, we're seeing the phosphate layers. That's a heart. They came back from a heart, and it is a heart. It's quite easy to see, and so is Psyche. All right, so there it is. Here's your heart muscle. There's your heart muscle from Psyche. I mean from Bennu, which is Bennu is right there, and there's the heart valves right here. There's one here, and there's the big, big one is right here. And this one here is not as easily to make out as a heart, but it's quite, you know, if you're a heart surgeon, you looked at it and you say, that's a crusted over heart. You can't miss it. They pop right off. I'll show you exactly how it does it. And they all do it. This is Bennu. I mean, the other one was Bennu. This is Psyche. That's I think it's 170 miles wide at the widest. 170 miles. That's a tube coming out. That's a tube coming out. These are valves, heart valves. There is not a surgeon on earth that does heart surgery that would not understand this. These are the colors of blood, the red, the yellow, and the black. This is the tendon that locks the muscle so that the heart can do its constrictions. This is all biology, and that's a tube. That's a tube. There's no mistake here. And this is a true picture. This is no artist rendition. You see this? I showed you that tendon wrapped around her. This stuff here, the plumbing at the top, is literally glued. It's just basically glued on there. And when that comes off, you end up with this. That's exactly the same. No difference whatsoever. And they have that stuff in their hands, and it is sarcomeres right there. With the phosphate surprise, wow, these layers of phosphate, what the hell's going on there? And these are sarcomeres, these are muscle sarcomeres. There is just no question about this. It's undeniable. And these are the sarcomeres in the heart on the earth, and it has the phosphate layers, the same, identical, same thing. No difference whatsoever. All right, 67P and Bennu, they're both hearts. This is a hip joint. So they're just exactly right there, same thing. Identical, I'll show you, and there's, you have the artery, you have all that stuff. It broke about here. They break in various places, but that one is there. Now, let's look at it as it's gassing off. You see that? That's an artery. The only reason these things are gassing off is because they're being cooked. It's like they're being cooked on a grill, only it's just radiation that's cooking them. And it's got to get down into where the red blood, where you got a lot of gas conversions going on. And it's just like smoke coming off your barbecue grill. Well, there's not enough oxygen to combust. These are shooting out from the little, blood vessels. And that one there is the artery. And this is that hip joint. And this goes back to 2015. So this has been going on a while. I try to contact everybody about this. So that's a hip joint. And it's blowing out smoke. And if you look at it close up here, you can actually see the bundles where the muscle was. And that's just blood cells primarily running off. And these little stripes here, that's tendon. And this bundle right here is a bundle of muscle. Because that's got to pull this way, pull that way, and so forth. There's a lot of action going on in your hips. If you're moving around good. Now, this artery, I showed you the smoke coming out of there, or the juices boiling out. It's almost 500 feet across. And all these little balls there, they call them dragon balls. Those are little balls, every one of those is a blood vessel that goes in to service the muscle and all the other tissues that are around there. So that's this one here, that's 67P. I showed you where it is in this. Now, they went up to Bennu, picked this up, the muscle. I showed you that, and I showed you Bennu. Now what about Oumuamua? Well, here it is right here. And what is Oumuamua? I can tell you exactly what it is. It's a finger. Now this came from out of our solar system. So is our solar system just the only place where there's biology? No. This is a finger. Now, you say, oh, Roger, that's not a finger. Well, let's take a look at that accusation, because I say, yes, it is a finger. And this right here at the very tip is grip skin. Just like on your own finger. You got a leathery sort of out. That just peels right off. Starting right there, you have an apical tuft. I'll show you in some anatomical shots. And then this white strip coming down, and all the little fibers right here is where the joint is for the fingertip. That's the knuckle right there. Up here, you have another one, but you don't see it quite. This is the main one. This is just a flexor type thing. This one here really does some work. And the other side of it invests the same way, and then that white comes all the way down over the top, see? All the way down like that. Over the top of the finger on the other side. On the bottom, you have some tough stuff too, but not like over the top. And then when it comes to the knuckle right there, that's where the tendons come in across the top. That's a vein, and that's the artery. That is a finger, and I showed this to anatomist people, and nobody has disputed that whatsoever. If you can find somebody to dispute it, I want to know why. That is grip skin right there. Now, this came in from some other area in the universe, I don't know where. So I would say the universe is homogeneously biological. I thought I showed you this, but maybe not. I just wanted you to be sure to understand these membranes, like they brought back from Bennu, are primarily made of phospholipids, contain a phosphate-linked hydrophilic head. That's every layer is made of these phosphate-linked particles, and it's a double layer which protects you from whatever's out there from inside, and selectively lets things in and out. Very sophisticated phosphate groups on both every layer, and that's what they found. They called it the phosphate surprise. All right, I showed you the samples from Bennu. Here's what they have to say: a phosphate surprise. That's that white stuff, and those are the membranes. Analysis of Bennu unveiled intriguing insights into the asteroid's composition, dominated by clay minerals, which we are 100 pounds of clay. Anyway, some of us more, some of us less. But it's dominated by clay, particularly serpentine, which is nothing more than flesh. The sample mirrors the type of rock found at mid-ocean ridges on Earth. Yes, because that's the same thing. Where material from the mantle, the layer beneath Earth's crust, encounters the water, they're washing down into the sarcomeres. Yes, Earth is the same thing. This interaction doesn't just result in clay formation, it also gives rise to a variety of minerals like carbonate, iron oxides, which is blood, iron sulfides, which is a product of blood, but the most unexpected discovery, the presence of water-soluble phosphates. These compounds are components of biochemistry for all known life on Earth today, and they refuse to discuss this with us or me. Okay, shocker du jour. Psyche, which I showed you, the heart, is a potato-shaped object about 173 miles, which is 280 kilometers by 144 miles. The thing is basically round, but the longest is 173 miles, 280 kilometers. Now, this is Stefan Burns, and he's talking about this absolutely enormous, something half the size of the sun. Well, they're talking about the particles and so forth, but they're estimating it to be only 50 kilometers. That's chump change compared to this guy here. It's 280. It's like 5 times or somewhere in that area. Anyway, and they're showing it as a metal asteroid, meteorite, whatever you want to call it, and it's supposedly coming in just as Oumuamua did from outside our solar system, and it's gassing off, and they're going to try to figure out what it is. All right, I have a meteorite right here. It came through space, and it's a fingertip. This is the apical tuft right here. And it comes down, and this right here is where the tendon locked in. You see it, all that stuff burnt off. Everything that could burn off, burnt off. And that's the structure of it. Now, looking at it from here, you can see this whole side is blown off. It should have been squared up just like this side. And that's this right here. Now, looking at it from the bottom, you can see. You see that circle, and that circle? You see that circle? You can't miss it. You see that circle? You cannot miss that. This one is missing. Those two were there, and that's where tendons and so forth locked in. And this side was where the red blood ran up, and red blood stays wet, and I mean wet. When it came through the ionosphere, the real hot spot that cooks it, it boiled off and just exploded right out. Now, I drilled a hole into there to get some red blood out of there, which I did, but nobody will test it. They don't want to get involved. This right here is that anchor down inside where the tendon anchors to. It doesn't just lay there on the surface. It comes down into that ball right there. And there's another one over on this side. And that one fed down into that ball. You see the ball is right there? That's what that locked in. This side just blew right off. but the ball is still in there. And that's the neck of the ball. And that wrapped over and came down here to hook in with all these other tendons. So there's the 3 spots right there. There's 1, there's 2, and the other one is exploded out. And that's red blood. That's because it's red, it explodes. This side here, you can see that? That's one of the veins, and the other vein is right up in this area here. This had 2 red arteries. This is at the terminus of your fingers and toes. The red blood comes down and it comes back up black. See how black it is here? See how red it is here? And this is a meteorite. I have right here in my shop. It's a body part. And I have another one too. I have a lung. And they're not uncommon. That's all there is. You see that? There's an iron meteorite. That's the vein blood and that's the artery blood. You see the red? You see the black? All these are different metals, these different colorations, and they flocculate together. They come together as partners. And here's another supposed to be a meteorite. Chondrules are nothing more than the balls that are in your skin. That's an artery. This, I don't know what it is. They say it's the oldest material in the solar system. That's all there is biology. I don't know what they got to come to grips with this. And here's that iron meteorite. They're everywhere. That's solid red blood. Now, what this was, I'm not sure. But some of them, the ones that were lungs like this didn't come through space. It just washed out. But the ones that were lungs, they turned into a lot of metal, but a lot of holes. The biggest one, the Oumuamua, I don't know if the biggest, but it's pretty damn big. This one right here, that's one of these. That's a lung. And when it came through space, it just cooked off and smelted. And if you look right down there, very closely, you see that? That's a blood vessel. They're all over the place in here. You can find them, but it's to me, it's just so obvious. I can't possibly imagine somebody not seeing this. Now, the crazy thing is, I have a fingertip from here on Earth that is identical to this. Not quite the same size, but the same. See, here's your vein and your vein right there. That hook, you see that hook? The exact same hook. That's where that tendon locked in up here. You see this side? Same thing. This one just gotten flattened out and squished out and the blood ran out. But this is where the red blood was. That's red blood in there. Those 2 spots. And this is identical. And at the very tip, it has the red blood. Same thing. This side has the vein. Exactly the same. And not only that, you see that little scruffy looking spot? You see that scruffy looking spot? Same place. This one just got flattened out here on Earth. And I drilled a hole in this to get DNA. Nobody will do that either. So I had a guy who was willing to pay for the DNA test. I said, I'm not paying anymore. He said, I'll pay. You could just get the stuff. I did. He sent me like 25 different DNA test kits, and I got ready for a whole batch of them, and nobody will do it. So that's where we sit today. This one did not come through space. This one did. And I rub them, I touch them, yes. When I go to get the DNA, I clean them up really good first. I make sure I'm all prepped up, and I drill down inside, and then I clean that up, and then I drill again, and I get the sample. And they've come back as, I had 3 of them done, because they did it originally in I don't know, it's over 10 years ago. And they came back as Homo sapien mitochondrial DNA. All right, that points towards a species. And I have the tests. I've shown them over and over and over. So I have hidden nothing, and I have had 0 questions from all of the places that I presented this to. And I presented this evidence to literally everybody that is supposed to be an educator. And I have had 0 responses other than just, I'm crazy. I was told I was a disgrace to science. I'm a tinfoil hat guy. Pareidolia. I'm lost. How could anybody be such a fool? I could go on for a week. But a question? No. How'd you do this? Where'd this come from? No, nothing. And I have all these things in my possession, in my hands. I have other ones here. Here's a tiny lung. They come big, they come small, they go every different size. And not only that, this here, in the microscope, you can see the flap. There's a little flap on every single lung that attaches it in the body. And this one has it too. And it's also magnetic because it's smelted coming through. And this one's just tiny. Now, so there's big ones, there's small ones. We live in a biological universe. And here's the moons. That's biology right there. That was attached. That's what's called a tendon enthesis. It's a ball that locks in your body somewhere, and a little strap comes out. It's the same ball as this one here. Same as this, only this one's a little blown off, but that's where that would have come out of the top. Now, I don't know, that could have come from a fingertip. I could have come from anywhere. And everything that locks you into something else has to have one of these balls. They're the enthesis. I'm going to leave it at that. So, I'd like to hear from somebody. Look at this one here. That rim around her, I think this is IO. And here's some of them have 2 places that lock in, some of them only have 1. And this one is a different style, has a ridge around it. And they lock in, sometimes they lock into bones, sometimes they lock into tendons, sometimes they lock into other forms of tissue. And when they do, sometimes they'll have a ring around them like this one does. And sometimes they'll have more than one strap, because some of these balls are just stone. In your body even. I don't know if they need, I'm sure they need to be taken care of in some manner. There's got to be some fluids to enter in and out, I would think. But I can't tell, because these are the Moki marbles and the Mars blueberries. They're just stones. When they're done and eroded, all that's left is a hard stone. See this? I showed you where they attach like that, and they break right off here. And they usually have a center little spot, which I had shown you. That's it right there. This is basically identical to that. And all those little pock marks are not there from impacts. Those are there for anchors. That's inside of flesh, so it won't be pulled out. If it's smooth, it just could pull right out. When they're like this, they don't come out of there. The straps will break, and that can be extremely painful. Trust me, I know firsthand. Now, once they erode, they're just the stone balls left over. And then, of course, the mud that they were embedded in just washes away. This is on Earth. These are called the Moki marbles. They're in Utah, Arizona, but they're also on Mars, too. They're called the Mars blueberries, identical. There is nothing that is in biology. And here's what they look like sometimes. There's different configurations of them. Hello. All right, Stefan Burns is talking about plasma. That's basically plasma. This is the smallest particles they've ever seen. This is directly from Fermilab. This is not my picture. This is. We were able to see these particles using laser, not big bombs smashing them together. And we could see these attached together as dipoles. Back-to-back dipoles makes a stable photon. Using a Venturi, which is just a tuned little slit, and it forces all these particles to come in and converge here, and it just explodes. And when it exploded, we created actual muons and electron showers, muon neutrinos And electron neutrinos turn into electron showers. We did all this. I've shown this thousands, literally thousands of times since about 2013 or so. And I have not been able to show this to anybody that has any meaning in this field and is spending our billions of dollars. They refuse to engage. And I have found this over and over, every single thing that I present. All of this stuff about the comets and the gassing off and all of this, I tried to engage with all of these people, and they block me. I'm blocked from every single venue. I cannot talk to anybody. They will not respond back. And if you can't help, we're screwed. It's been like this for years and years and years now. And I got guys doing better work. This is from Mason, who's doing some unbelievable work with a Newtonian telescope, looking at all of these very, very subtle changes in energetic values using CMOS, which was my original discovery, that CMOS was the key to picking all this up. And I fought with all of them. I went to the University of Geneva for particle physics and talked to them about it. And I said, you guys got to start understanding the CMOS. And eventually they did, and they started using CMOS. You see the black and the white? Look at this. Everything's a dipole. That's Saturn. And Mason is just off the charts with this stuff. He's really doing some fabulous work. Now this is ISON, I-S-O-N. I don't know, but I can tell you what it is. This thing here is coming this direction. Whenever you see a bunch of glow in front, it's pushing hard against that stuff, and everything in front of it will start to glow like crazy. So it's not going this way, it's going that way. And all of it's quite evident. And look at this. Look at the stuff he's seeing out there. What's this all about? Now, is this within our atmosphere, or is that outside of our atmosphere? These are the things we've got to figure out for sure. I've been working with them, and we're trying to, because you look at this, you see, what the hell is going on there? These real glowy ones, as far in my mind, they have to be stars, or have to be something that's illuminating, is blowing out light. But what about these little ones? The little white light dots. I think I have an explanation for those too, but that's for another time. There's so much to think about here that it's overwhelming, but it's fun. All right, this I would like to be involved in it, because they're looking at the spectrum of particles that are given off in the radiation of the coma, and they're scattering light. And this one here is carbon dioxide, and this is some kind of carbon oxides, and this is water, I guess. And it goes on, and they're picking up all these different chemical signatures, which is exactly the same thing they did when the Philae lander went to 67P. And I have all that information. I have all those spectroscopic images and what they found. And it's all biology, just like this is all biology too. 100%. All right, he's just saying that this is outside of our atmosphere, the Webb telescope. It's outside of the atmosphere, so it's not corrupted by that. So it's out here taking these, and they can see extremely accurate gases very well, which normally you just can't see them. And it has a very low frequency. You can see down into the infrared, way down into here, almost into radio waves. Well, probably you could, I don't know. All right, everything just ties with everything else. He's talking about dipole electron flood theory, because he's talking about plasmas. Plasmas are the dipole electrons. They're and then they start to build up and create what he calls dust. They accumulate, and then they start to grow into particles. Actually, they start down in the proton range. We're in the plasma. There's no protons there at all yet. Protons are a blob of plasma, like this. Plasma is down around here. Little bitty things they're just dipoles. When they all get together enough, they start to create protons. and they become stable at about 1839, somewhere around there. And at that point, they start to turn into building blocks. And that's what he's talking about, making dust. All right, once again, everything touches everything else. The anatomy of a proton is nothing like what they told you in physics. Protons have a dark core and a bright surrounding, all the particles surrounding them. There's a certain number of these, and they always stay the same size. They won't break, that I know of. And they are solid. They have a mass. These have no mass, nothing but energy. They can get big, they can get small. These never change, and they have a certain mass. And this is what is plasma, basically, is this sort of stuff floating around. And we have created that using the dipole electron flood theory and the Venturi. And there's going to be some changes. And that's the only way it works. They admit nobody can figure out quantum mechanics until you start using the dipole electron flood theory. And I have evidence of this. It's not just I'm making these things up and I'm just guessing. I can show you this. I suppose I have to.